Alright, so now we're going to take a look at interest compounded continuously. When you looked at the previous video, and I hope you have, we saw that we were compounding, let's say we were compounding yearly, we might have been compounded semi-annually, you might have been compounded quarterly or monthly, right? And so the more you compound, right, then the more you're going to make, right? Because the more often that the bank is going to give you interest, which means they're going to then give you interest on interest. And so the issue though is if we take a look at that previous function, excuse me, at that previous, there's the formula, this previous formula. If I take a look at this and I continue to increase my n, right, to not yearly but semi-annually, annually to quarterly, quarterly to monthly, monthly to daily, if I continue, maybe even hourly, if I continue to do that, increase n, as n gets really, really big, as n gets like close to infinity, this amount right here actually approaches this amount right here. And it's a calculus explanation we're not going to get into, but just suffice it to say that when you see the words continuously compounded, compounded continuously, you're not going to use this formula, okay? It's still a financial calculation, but it's not going to be that formula. It's going to be the continuous compounding formula, okay? It's actually a limiting situation. It doesn't continue to give you more and more money as the n increases. It actually approaches a limit. So that's the formula. Okay, so the P and the A are the same things, and the E to the RT is taking the place of the 1 plus R over N to the NT. Okay, let's take a look at using this equation, or this formula. Find the amount when $12,000 is invested, so my P is 12,000, is invested at 5.5% compounded continuously. So I know I'm going to use my PERT. I call it the PERT formula. So let's get this in percent interest rate into a decimal. That's going to be 0.055. And so that's my R, right? Compounded continuously just means I'm going to use that formula. And then for 6 years, that's my T. T is 6. Now notice I don't have an N. Why don't I have an N? Because I'm not using this formula. I'm using this, and it's replacing all of that other stuff, the E to the RT. Okay, now E, by the way, is not a variable. E is, if you look on your calculator, E is approximately 2.71. In one of the other videos, I referred to that value. It's like pi. It's an irrational number, but we're not going to get into how we get that number, but it's part of the formula, so we're going to use it. So I actually just write E right there, and when I put it in the calculator, the E is going to turn into that irrational number, and it'll calculate everything for me. So now the other variable of R is going to be 0.055, and then times the 6. Excuse me, times the 6. There we go. Alright, so this is going to be turned into one number before I put it into my calculator. This is just the way I like to do it, right? So I'm going to go to my calculator and clear it up, and I'm going to say, what was that, 0.055 times 6, 0.055 times the 6. That's my decimal of 0.33, so that's going to be 0.33. So now I'm ready to put this into the calculator. I'm going to have A is equal to 12,000 times E to the 0.33 power. Alright, let's see what we get. Okay, so clear 12,000 times, okay, and I'm going to go second division, which is going to get me that E. Then I'm going to raise it to the power of 0.33 and enter. 16,691.62, 16,691.62, 16,691.62. And there it is. It's going to be compounded continuously for 6 years. This amount of money, 12,000, is going to turn into 16,691-ish. Okay, let's take a look at one more example. Find the amount when 4,000 compounded continuously. So immediately I know I'm going to use this formula, right? Okay, compounded, let's see, 4,000 is invested, oh, let me get that, 0.032, okay? It's going to be times e to the 0.032 power, but times 8, okay? That's the t is 8, my r is 0.032. And again, there's no n because it's compounded continuously. And here we go. Let's get that into the calculator. 0.032 times 8. 0.032 times 8. 0.256. So this is going to be 0.256. And here we go. 40,000. Whoa, 4,000, excuse me. 4,000 e to the 0.256 is approximately 4,000 e to the 0.256. 4,000 times e to the power of 0.256. Let me make sure I did that correctly. Yep. Okay. And here we go. 5167 and a penny. 5167.01. And there it is. 4,000 turns into 5,167, and all you put in was originally 4,000. That means the bank, you earned interest of $1,167.01. So, hope this was helpful. Oh, good night, nurse. Okay, I'm going to have to back up. Do you notice it says 8 years and 2 months? Geez Louise. Okay, 8 years. My bad. Let me back this up just a bit. That's okay. We're going to be fine. 8 years, 2 months. I threw this in here on purpose, right? And I totally forgot. This is going to need to be turned into a decimal. In other words, excuse me, a number that is the number of years and a portion of a year. So think about it, 8 years and 2 out of 12 months, right? Because it has to be in years. Can't even put months in there. So this is going to be what, 8 and a sixth, okay? And so I'm going to just turn that into an improper fraction because I don't even want to. I don't want to round it. 6 times 8 is 48. This will be 49/6. That's how many years that I'm going to put in. Sorry about that. So that's to the 0.032. Okay. The time that we're leaving that in there is 8 years and 2 months. So I couldn't forget that portion of the next year. It's a portion, right? 2/12. So 49/6. All right, that's just basically 8 and a sixth. All right, so now let me get that number. 0.032 times 49/6. Excuse me, didn't mean to do that. 0.032 times 49/6. And we get 0.26 and 1, 3 repeating. 3, 3, 3. I'm going to go ahead and leave 3 on there just like that, and let's see what we get. Excuse me. So 4,000 e to the 0.261 and a bunch of 3's. 4,000 times e to the power of, I already forgot, 0.261 and a bunch of 3's. All right, and I'm going to go ahead and enter. There it is. 5194. Didn't make a whole lot of difference, did it? But I don't want to leave out the 2 months. So 5194.64. 5194.64. Okay, so, we don't want to leave out the amount of money that the 2 months would actually give us. So thanks for watching. Hope this was helpful.